Assalamualaikum and very good day to everyone. Today, our group will be discussing about wind turbine. My name is Muhammad Amirul Aiman bin Jamaluddin, number matric S71511. This is our group member Muhammad Nifa'il, Muhammad Hafiz, Muhammad Haikal and Jubian. First, I will be leading the introduction. So, what is wind turbine? Wind turbine is a major renewable energy source, being the converter from the kinetic energy of the wind to electrical power. What is part of a wind turbine? The generator is one of the most critical part of a wind turbine electrical system and usually work at high voltage. What is partial discharge? Partial discharge is a localized electrical discharge within high voltage equipment insulation that ultimately can result in catastrophic equipment failure without remedial measures. Instrument of wind turbine, which is partial discharge detector, monitors and identifies partial discharge (PD) activity in wind turbine generators. Use advanced sensor and diagnostics to detect early sign of insulation degradation. Enables preventive maintenance, reducing the risk of costly breakdown. Analyze PD signal to determine the severity and location of the issue. Help schedule repairs during non-peak time, minimizing downtime and maintaining energy output.
The next topic is theory of wind turbine. The basic concept of physics is electromagnetic induction. Wind turbines convert wind kinetic energy into electrical energy. Spinning blades drive a generator with two main components, which is rotor and stator. Rotor is the rotating magnetic field, while stator is stationary windings. Changing magnetic flux between the rotor and stator induces electromotive force. This process, based on Faraday's law of induction, generates electricity. The second concept is dielectric breakdown and partial discharge. Partial discharge occurs in the insulation system of electrical component. For example, is stator windings. When the local electrical field exceeds the dielectrical strength of the material but does not cause complete insulation failure. PD is a result of microscopic defect, void, or imperfection in this insulation. Over time, this discharge can degrade the insulation, potentially leading to equipment failure. Here are the basic physics concepts explained clearly. The first basic physics concept is kinetic energy and energy conversion. The concept is wind turbine harness the kinetic energy of moving air and convert it into electrical energy. The physics is Ke equal to 1 divided by 2 times mv square, where m is the mass of the air and v is its velocity. The turbine blades are designed to capture this kinetic energy efficiently and transfer it to the rotor. The second basic concept of physics is electromagnetic induction, Faraday's law. The concept is electricity is generated in wind turbine using Faraday's law of electromagnetic induction. The physics is EMF equal to negative N d magnetic flux divided by dt. The last basic concept of physics is partial discharge and breakdown. The concept is partial discharge occurs when small, localized areas of an insulating material experience a breakdown due to high electric field. The physics is PD does not cause a complete electrical short circuit, but generate high frequency pulse and weakens the material over time. PD is common in defects such as void, crack, or impurities in insulation.
So we move to the next slide, which is a basic concept of physics in development of wind turbine. So the first one is aerodynamic and blade design. The first point is lift and drag forces. Wind turbine blades are specifically designed to maximize efficiency in their operation. The blade shapes are developed in a way that generates lift of force that allows the turbine to rotate once wind is blown over it. There is an optimum angle of attack, the angle between the incoming wind and the blade section, that is set to augment lift with minimal drag forces. The second point is blade shape. The elaborate shape of the blades is designed in a way to optimize airflow, reducing turbulence to a minimum to keep the rotation steady and efficient. So the next is energy conversion principles. So the first point is kinetic energy of wine. Wine possesses kinetic energy, which is given by the formula K equals to 1 per 2 mv nv square, where m is a massive of the air and v is the wind speed. This power may represented mathi- mathematically as P equals to A multiple P multiple V over 3 per 2, where P is the power extracted from a wine in watts. A is a swept area by the blades of the wind turbine in square meters. P is the air density in kilograms per cube meter or kg per m3, and v is the wind velocity in meter per second. So we move to the next slide, which is Betts law. So this is a principle that say no wind turbine can capture more than 59.3% of the kinetic energy in wind. The maximum efficiency is a normal referred as a Bird's limit and is divided from conservation law of mass and momentum. So in a simple terms, the faster the tip, the more efficient the turbine. So we move to the next slide. So the first one is mechanical and structural considerations. The first point is torque and rotation. The interaction of wind with the blades generate torque, which is the rotational force that turns the turbine. The design must ensure that the turbine can withstand the mechanical stresses caused by wind forces. Second point is pitch control. The blade pitch can be altered in order to operate under optimized conditions and safeguard the turbine from high wind forces. This is typically accomplished by adjusting the blade angles with respect to wind direction for control of both the rotor speed and electrical output. The second one is safety features. The first one is braking systems. Turbines are installed with braking system that work under very bad weather conditions and strong winds. It is possible to feather or orient the blades in a neutral position to stop producing torque, or electromagnetic brakes may also lock the rotor. So the third is measuring efficiency. The first point is power curve. The performance of a wind turbine can be shown in power curve, depicting the relationship between the wind speed and power output. These are obtained experimentally and assist in evaluating different turbine designed for their efficiencies.
Furthermore, we're going to move on with application of wind turbine. So this is working principle of a wind turbine with a partial discharge detector instrument. Firstly, wind turbine use the wind motion or kinetic energy to turn the blades, connecting to the rotor, then to convert the wind's kinetic energy into electrical energy. Most turbines use a gearbox that converts the rotational speed of the rotor to run the generator. The generator produces three-phase electricity, fed into the public grid through a step-down transformer. Lastly, the electricity is then generated by the generator and through transformer, it is transmitted and then delivered onto the electrical grid. So the next application of wind turbine is partial discharge phenomena in wind turbines. Partial discharge are localized electrical discharge which occur in insulation materials or at the interface between dissimilar materials, unless the electrodes are breached completely. The partial discharge degrade insulation and may compromise system integrity over time. Partial discharge are generally caused in wind turbine by insulation system or high voltage component such as generator, transformer, and cables. The source may also be stress concentration at sharp edge or air gaps in insulation or from the aging or manufacturing defects in the insulation material. Next, the third application of wind turbine is partial discharge detection in wind turbines. Partial discharge detection purpose includes monitoring the partial discharge activity, assessing the partial discharge insulation health, and predicting a potential PF. Measurement techniques are commonly ultrasonic detection of sound wave induced by partial discharge, electromagnetic sensor based on signal generated during a discharge in high frequency area, optical methods involving observation of light emission made under laboratory condition, and transient earth voltage TEV based on detection of electromagnetic wave from partial discharge by metallic sensor. Taken together, this method offer insight into the way flexural insulation can be maintained. Lastly, the working mechanism. The partial discharge detection system continually monitor insulation components in real time or periodically during inspection while the wind turbine operates. During a partial discharge event, the system records magnitude, frequency, and repetition rate of the activity detected by the sensors. The partial discharge pattern are then correlated by analysis software by potential faults. When critical partial discharge levels are detected, the system is notified by alarms or reports what needed maintenance action are to take to prevent further damage and maintaining the system reliability.
For the conclusion, a partial discharge PD detector system is important for keeping wind turbine reliable and lasting longer. It monitor the insulation, detect partial discharge and give alert for maintenance. This helps prevent major equipment failures, keep the wind turbine running well, and support sustainable energy production. NPD detection to wind turbine maintenance help improve energy generation and ensure the turbine operate efficiently for a long time.